Welcome everyone to a wonderful edition of Math 211. We are now in finishing week 11, so this will be our 22nd lecture, unless we missed one. I don't think we did. And today is going to be a review of chapters 7 to 14. This will be on my YouTube channel. Please like and subscribe. And let's get started with chapter 7, which was the definition of expected value. Now, we went through a bunch of things in terms of examples, kind of explaining what we're doing and leading up to it. These are all examples. But at the end of the day, this is our first formula for expected value. The expected value formula. So you look at all the possible outcomes, you look at all the possible probabilities, you multiply them together and you add them. Namira is here, so remind me later because I don't want to stop now, if that's okay. So the expected value of a random variable of a situation is you look at all possible numerical outcomes, you multiply those numerical outcomes by the corresponding probabilities, and you add them together. This is on page slide 9, in case you want to look later. So then we had example, and we had examples, and we had examples, and we had examples. And this was a very short chapter, right? In hindsight, at least. Lots of examples illustrating this one idea of expected value. Now, in this chapter, we also had the concept of fair value, I believe. I don't think it was the next chapter. I think it was this chapter. So, Larry, you had a question?
Yeah, I was going to ask about slide 12.
Slide 12.
Because remember how on our exam we had an issue of calculating the initial payment?
Yes. So be very careful of the wording of a problem. Okay. Some problems might be worded, what is your expected return? Or what is the expected amount that you will receive? In which case you do not take into account how much you paid to play the game itself. And others are your expected profits, in which case you do take into account how much you paid to play the game. Okay, so just be aware of the reading. It should be self-explanatory, hopefully, which one it's referring to based upon the quotation, based upon how it's read. But I did see there the fair amounts you pay. Remember, fair amount is related to expected value in the sense that the fair amount that you pay is the amount that will make the expected value equal to 0. Okay, that means we don't expect to get anything. We don't expect to give anything, right? The expected value is 0. It's a fair game. So this is chapter 7. 2 concepts with a lot of examples thrown in. In the interest of making sure we cover everything, let's now move to chapter 8. Unless there's specifically a question on that, I'm now, oh, actually I can still share. I'm now going to go back, and now we'll do chapter 8, which was on randomness and runs. And in the absence of questions, I'll just assume that there are none because, again, as amazing as I am not clairvoyant. So here we go, randomness and runs. So in this chapter, we certainly talked about, I remember we first started with kind of investigating which of these was the more random sequence. And a lot of people would say the first one because there's too many streaks in number 2, too many runs. But actually, as we saw, it's the runs that actually make it more random, because in reality, you're going to have runs, and therefore not having runs is kind of suspicious. Okay, so a true random sequence is going to have runs of various amounts. So here on slide 2, we have, oh, this is just a question, so never mind that one. But here we have the law of small numbers and the law of averages, both of which are not valid. They're not real things. They're things people say when they pretend that they know what they're talking about. Okay, they are not real things. The law of small numbers and the law of averages are explanations for why things occur that are not accurate. The only thing that's accurate is the law of large numbers. Okay, the law of large numbers is the only thing that's accurate. It says in the long run, you expect to have the value approach what it should. There's no averaging out. Oh, I had a lot of weird values here, so I'll average them out later, and that's how it's going to balance. No, nothing like that. There's no averaging. It's just the fact that as you go to infinity, as the number of trials increases, you narrow in on the true value of whatever it is that you're looking for. Okay, that's the law of large numbers. So we did some more questions, more examples. I remember this example was kind of nice. A lot of people think that because in this example, green is going to happen 4 out of 6 times, and red's going to happen 2 out of 6 times, that you expect to occur is the first one, because hey, there's 4 greens and there's 2 reds, so that's correct. But it's not asking in this case. You got to be very careful what the question is. The difference between what's the likelihood of having 4 greens and 2 reds versus the likelihood of having this specific sequence of 4 greens and 2 reds. Because this specific sequence has a red in that spot and that spot. But for each of those 2 roles, green was more likely, because green is always more likely. So it's actually the second one that was a more likely sequence. And the second one, of course, has runs. So, runs are something that you should expect to have.
Expect to have in general, or expect to have in the test?
No, in general, when you have, that's a good point. When you have a situation of lots of events in succession, you expect to have runs. Good. And because this test has a chapter of runs, you should expect to have a question on runs. So there's 2 expected things going on here. So yeah, fun times. Okay. I remember the birthday paradox, lots of fun, but not, again, you're not going to have that in the test or anything like that. This chapter was, I think, mostly qualitative. I don't really see any major formulas or anything. It was just the ideas of randomness and the ideas of sequences. Anyone remember anything or any have questions about this chapter? Because it doesn't look like there really is much here.
The multiplication rule for independent events, maybe?
So the multiplication rule for independent events is kind of like the following. If you are getting dressed in the morning and you have 10 shirts to wear and 3 pairs of pants to wear, and I ask you how many outfits you have, you say, well, I have 10 of these and 3 of these, so I have 30 outfits.
Got it.
Because for each of these 10, it could be any one of these 3. The independent events is the same idea. If you do 2 things or more in succession that are independent of each other, that have nothing to do with each other, and you count how many outcomes there are for this one and for this one and for this one, and you want to know how many outcomes there are in total, you just multiply the number of outcomes for the first, number of outcomes for the second, number of outcomes for the third. It gives you the total number of outcomes. The same thing applies for probability. If I roll a die, which the probability of 1/6 of getting a 1, and I flip a coin, which is probably a 1/2 of getting a heads, and I say, well, how likely is getting a 1 and a head? Well, they're independent. They got nothing to do with each other. So 1/6 times 1/2, you get 1/12. And so the law of independent events is essentially, or the multiplication rule, is that you just multiply the probabilities. Just don't try to use that rule in a situation where either they're not independent or you don't know that they're independent. Okay, because what happens then is you use a rule in a situation where you're not allowed to. What happens when you use a rule in a situation when you're not allowed to? You get answers that make no sense. Okay, so this was chapter 8, randomness and runs. Not a lot of there mathematically. We skipped number 9. And then we went into chapter number 10. So chapter 10, displaying quantitative data. And now this was where the more descriptive nature of statistics came into play. And in the descriptive section, we had a number of ways of describing data. And we divided data into 2 kinds. There's quantitative data, which is more of a numerical nature. And then there's categorical data, which are categories, which might be numbers like, for example, how many people have one kid and how many people have two kids and how many have three kids. We lump them into categories. Or how many people live in 90210 or 904-1217, whatever the numbers are for zip codes, right? So you can have numbers be categories, but numbers, of course, could also be quantitative. You can do math with them. You can average them. You can add numbers and divide numbers and multiply and get things that make sense. So when it came to categorical data, we had a couple ways of describing them, namely a bar graph and a pie charts. I think we covered those, I'm pretty sure. But this chapter is on quantitative data. And we saw that when we describe quantitative data, we have a few different methods of doing so. Okay, and the first one was a dot plot. Okay, I think a dot plot is rather self-explanatory. What is a dot plot? You put a dot at each value to represent how many have that value. And the column of dots represents how likely, in some sense, it is for that outcome to occur. If there's more dots, it occurred a lot of times. If there's fewer dots, it occurred fewer times. If there's no dots, it never occurred, right? So dot plots are very informative. And then we had some examples of them. And we had people making good dot plots and bad dot plots. So you should know, the features of a dot plot and what is the appropriate thing to do in that situation. We also had a histogram. And we saw that a histogram is kind of like a dot plot, but the big difference is that rather than having dots for each possible value, we separate it and we group them together into bins. And you have more than one possible value in a bin. What is the disadvantage of doing it this way? Is anyone remember the big disadvantage for this?
You can't see the individual values.
Awesome. You can't see the individual values. I know they fell somewhere in the bin, but where do they fall? I don't know. I lost that information. What's the advantage? Well, if you have lots and lots of dots, like a million dots, it's very difficult to plot a million dots or even 1,000 dots or even 100 dots. So the larger the collection of data, the more difficult it is to graph it. As such, histograms certainly have their uses. And each histogram is essentially counting how many values fell in that bin. So that when I have the column, it tells me how many. So 8 in the first bin. I'm sorry, Megan, this is so boring. I apologize.
No, I've been working all day. I'm sorry.
I've been working also. I am exhausted. So I hear you. Okay, so you have 8 in the first bin, you have 11 in the second bin, and 6 in the third bin, and so on. Remember also that the edges of a bin, we have to decide whether to include them in the left or the right. What's the official rule for this class? Do they go left or do they go right? What do we always do in this class?
Right.
The right.
They go to the right. So just remember that in case I, throw a curve at you and put you one right on the edge, okay? Each one has to have the same width, and you can have the frequency or the relative frequency. I might have percents, 12% in this one, 13% in this one, 14% in this one, and so on. You can also see if there's little gaps, and maybe there's an outlier, kind of easy to tell. Histograms also you can do, of course. Question?
Sorry, Professor, can you explain again when we move it to the right?
If it falls on the edge, if it falls right at this value here, you have to decide. You can't count it twice. You don't count it in each one. It didn't occur twice. So you have to decide, do I put it in the bin on the left or do I put it in the bin on the right? So we go to the right. That's the ruling for this class. So if I get a value of 10, which is the border of these two bins, I put it in this one. I put it in the bin on the right. Don't have to, but in this class we do. And of course, you can change the width of the bins, and then of course can possibly change the look of the histogram. And that's how some people skew their data. They can't change their data, but they can skew the perception of the data by changing its appearance, even though the data itself is accurate. So as I already mentioned, we can have the actual frequency or the relative frequency, which is what proportion of them occur. We did both. We look for clusters, we look for gaps, we look for outliers, we look for irregularities. We care about whether it's symmetric or skewed to the left or skewed to the right. Even if it is symmetric, We always care whether it's normal or not. Normal is a great property to have. It looks like this bell curve. Remember the last chapter in this test, the normal model. We love the bell curve situation. Very, very helpful. This is symmetric, just not normal at all. We care about where the center is. We care about how spread out they are. But remember, those are things that are coming in the next few chapters. The ideas of center and variability. We talked about that. And then as a statistician, you're kind of done. But then you want to interpret the statistics. You're kind of looking for why are their patterns the way they are. Is it because these ones are older or younger or male or female or this state or this country or that country or this nationality or that nationality? You try to look for explanations in your data. Otherwise, why even taking data? Then we had some more examples, and then we had stem plots, right? So we have dot plots, we have histograms, and now we have stem plots. And stem plot is kind of like a sideways histogram or a sideways dot plot, although it could be vertical. It doesn't have to be this way. And of course, so can the dot plot. Anything could be horizontal or vertical. It's up to you. But in this case, it's kind of like the dot plot in terms of each one being listed as opposed to the histogram. But it's kind of a shorthand notation where the first digit or all digits except for the last one are to the left of this vertical line. So you have 0, 3, 3, 3, 4, 4, 4, 4, all the way up to 35 in the very bottom. You don't list each number because numbers can get longer and longer and longer, but you do list the stem and then you list the leaves, and hopefully between them, you get the entire thing. So we did those examples as well. Again, I'm not teaching this. I'm just kind of doing a quick run through of what you have to know. And that is the end of chapter 10, unless there are questions on it. Not a question like, hey, I have no recollection of ever seeing this before. Can you teach it again? That's not the kind of question I mean, but something more along the lines of, is this going to be on a test? And can you remind me just quickly about this thing? And I'll get a quick answer, but okay. So nothing from chapter 10. Let's now move on to what you need to know for chapter 11. Okay, then that's solutions, chapter 11. And by the way, all solutions are up. So you should be checking all your work up to 14 to make sure. What the freak? Did I keep hitting the wrong one? I do keep hitting the wrong one. Do I want to go to this one? There we go. Okay. Measures of position. Okay, so essentially when we talk about position, we care about where the center of the graph is. Now, if it's normal, the center of the graph is very easy to determine. It's right in the middle. If it's not normal, then it's a little tougher. So what do we do when it's not normal? Well, we have multiple terms or formulas for how to compute the center of a distribution, okay? What are those terms? There's the mean, there's the median, and there's the mode, okay? So the first one we talked about was the median. Essentially, it's the halfway point. It's a point at which 50% are to the left and 50% are to the right, okay? We also said, well, what if I don't care only about the middle, which is 50%, 50%, but I want to know where 25% and then 75% are? And we had terms for those. You should make sure you understand them. You'll do the 25th and the 75th percentiles, right? We certainly did those as well, okay? And then not just the 25th and 75th percentile, we did percentiles in general. I can say, hey, where's 17% is less than this point? We talked about that as well, and you should certainly know about them. We had the cumulative percentile plot, which adds up all the percentiles up into some value. We definitely did some problems on that, and those were lots of fun. Notice that it always gets bigger because it's accumulating, and it ends at 100% because you eventually get everything. The quartiles are just another fancy word for the 25th and 75th percentile. So we call them the quartiles, the first quartile, the third quartile, the median being the second quartile. You should know those terms so that if you see those terms, you don't got to ask, hey, what does that mean, that term? I don't remember going over it in the class. Oh, no. We did go over it. Uh-oh, my dinner's coming, I think. Fantastic. A friend of mine actually went out and she caught a tuna. She didn't go out and buy tuna. She went out and she caught
Whoa.
tuna. Like, this, she showed me the picture. It's like half the size of her. So she gave me a bunch. So I'm going to try it. And hopefully it actually tastes like tuna. But I don't know if it will. We'll see. Anyways, so he's making it, you know, the good man. So we'll have this. All right. Anywho, so medians and quartiles, right? We talked about those. We did lots of examples with them, Q1, Q2, and Q3. Right, here are the examples. We did them, looked them over. And then we had the 5-number summary, which are the 5 numbers, the very smallest, Q1, Q2, Q3, and the maximum. We did all of those. And then we had the modified box plot as well, where you might have an outlier. We talked about them, the box plots, minimum, Q1, Q2, Q3, the maximum. We did all of that. A lot of fun times. Remember here we have an outlier, so we have a modified box plot. You don't go to the outlier, you stop at the non-outlier. Otherwise, it's exactly the same. And we have more examples, group activities, more examples, and then we're done with chapter 11. So are there any questions on chapter 11? And this is your time to ask. Or forever hold your peace. Or pieces. Or whatever you want to hold your peace. Huh?
No question for me.
You do? No question for Solaire? I just think Solaire speaks for everyone. So there must be no questions. So let's move on now to chapter 11. No, that was 11. I meant chapter 12. On the mean. Yes. So that was about the median, right? A lot of exciting stuff, the median. But now we'll talk about the mean, which is a little more mathematically complicated, unfortunately. Because unlike the median, where you just kind of line them up in order and pick the one in the middle, the mean actually has some math involved. Okay, so how do we find the mean? Well, the mean is your basic average from the 3rd grade. You took a bunch of tests. You want to know what your average score is. So what do? You add them all up and divide by how many tests you took. What do you think? Okay, we'll see how it goes.
All right.
I've never had real tuna before. I've had tuna fish, but is that really tuna? I don't know. And just so you know, guys, you can tune a piano, but you can't tune a fish. Just be aware of that.
Ha ha ha.
You know what?
Funny guy.
You know what? You just failed. Okay. You just failed. All right. Anywho, so we have the mean, which is you add up all the values and then you divide by how many you have. That gives you the mean. So we did example.
Wait, I have a question.
Yes.
Is your tuna, is it like a tuna steak or what is it?
It's like a slab of meat that we just put in the freezer.
Okay. Did you cook the whole thing?
Maybe.
Is it like cooked through?
Yeah, I hope so. Am I going to die if it's not?
No, it tastes better when it's not cooked through.
Oh.
But that's,
I don't know. That's not bad. It's not-
good.
It actually tastes like salmon. It doesn't taste like tuna fish. It actually tastes more like salmon does. So either he lied and he just said, well, this screwed up and threw it out and put salmon instead, or all fish taste the same. I don't know. Either way. Okay. So we have this example here, another example of calculating the mean. By the way, it's not a histogram. The bars are not next to each other. It's a bar graph, categories. But we have 5 for him, 10 for him, 7 for him or her, sorry, 10 for her, and so on. So you can get the values for the mean that you're going to add together. They're not always going to be given to you, like here's 3 and 5 and 7. You might have to figure them out yourself based upon the data as it's presented. Let's take a look. We had this weird formula here for determining the grade level. That's just an example. Okay, so talking about the mean, we had multiple conceptual understandings of the mean. All right, remember this. One was the equal redistribution method. You take your values and what you do is you kind of spread them out so they're even to everyone. And when you do that, and you spread them out so they're even to everyone, that value that you get would be the mean. Okay, that's the equal distribution method. Okay, which is one of the methods that we learned for having a conceptual understanding of what the mean represents. Okay, and we did some examples of that, and you should certainly, of course, be aware of that. That the leveling out method, right? You equally distribute it. So we did that for sure. And then let's see what else we have. Then we had the balance point method, which was the other technique. The balance point method is kind of where you can put your finger so that the distribution will be perfectly balanced. That is the same value as you would get from the redistribution technique, okay, which we talked about in class. And so you have three ways of figuring out the mean. One is the redistribution technique, one is the balance technique, and then the other one is the formula. The formula, I would say, is the best because it doesn't require any, conceptual understanding. It's just straight up plug it in, do the math, get your answer. So then at this point, we now have two different ways of thinking about the mean or the median. They're two different measures of center. And the question is, well, which one do I use? Do I want to use the mean or do I want to use the median? So as a general rule, if it's skewed data, we use the median. Because the mean, in a skewed situation, the mean will really be affected by the skewness, much more so than the median. So that the median is a more accurate representation of center than the mean. If it's not skewed, then we use the mean instead. Okay, so basically it comes down to skewness. So here, for example, it's very much skewed to the right. So I would use the median in that example. I wouldn't use the mean. Now some examples. And more mean stuff. And that's a baby. And then there's the weighted mean. We did one example of the weighted mean. It wasn't a big one, but we did one example of the weighted mean where you want to average values, but one value might be worth more than another. It's like if I give a test in my class and I say, this quiz is worth double, then you can't just say, oh, I got a 10 on one and 20 on the other. Hey, I got a 15 because it's worth double. It's got to be weighted more. So we did this example. It was only one example, but you know how to do it. Weighted means, okay? So that's basically all you do is you take your value and you multiply by the percentage of that value. So a GPA of 3 in this case, 15 of my 27 units were GPA of 3. So you would multiply by 15 over 27 and so on. So that takes care of chapter 12, unless there's another question on it. And then we move to chapter 13, which is the pair to center, and that's variability. And we're getting closer and closer to where we've ended. Variability is how spread out the data is. Okay, and when it comes to variability, there are multiple measures of variability that you can possibly use. And if you recall, we have 4 of them. One, which we never use. Who can recall which one we just never use? Because it's just bad. Which one do we just never use? Anyone? Sorry?
Mad?
The mad, it's true that the mad we don't use, but not never use.
Or the inner quartile?
Oh no, that's a great one. We love the interquartile range. Oh my God, gee, how can you say that? It's crazy.
Oh, Because I know standard
The
deviation
range.
is the most
The
important.
range, yeah, no, standard deviation is great. IQR is wonderful. The range is, blech. We never use the range. Okay, so, but you should know what it is, because I might say, hey, what's the range? And then I might say, do we want to use it? And you'd say, no, we don't want to use the range. We never use the range. But you can't say that if you don't know what it is. So there's the range, and then there's the interquartile range. So the interquartile range is much more useful. In fact, when would I use the interquartile range? When would I use the interquartile range? Anyone know when I would use that one? Use the IQR when you use the median. They go hand in hand. The IQR comes with the median. Okay, IQR comes with the median. The mean goes with what?
Average? That, I mean,
Huh?
I don't know.
The mean goes with the standard deviation.
Oh.
Okay. So, so you have the range. The range goes with nothing, but the IQR goes with the median, and the standard deviation goes with the mean. What about the MAD? What goes with the MAD? Nothing goes with the MAD. The MAD is only used as an example to illustrate this idea of spread from the mean, but we don't actually use it. We just use it as a lead-in to standard deviation. It's not really used, but on a math test, I could use it because I can just say, what's the MAD here? In fact, I'm probably more likely to do that. You know why? Why would it be more likely to do the MAD than the standard deviation?
It tells you how far all the data is from the mean.
No, not why it's important or not, but why is it, would I be more likely to ask about that than the standard deviation? Because it's easier. There's no square root. We're not squaring. We're not dividing by n-1, although we are dividing by n at the end. But it's just easier to do it than the MAD. So it might be not as useful, but from a test perspective, it's just easier. Okay, but you should certainly know what the MAD is because we covered it. And the IQR, the box plots, this. Yeah, we did all this stuff. We did a lot. I think you guys should be proud of how much you've learned this semester so far. We're not even over yet. Okay, hopefully you are. And you're like, this semester was stupid. I learned nothing. Because this is a lot of stuff. And no one's agreeing. So that sucks. But anyways, okay. So you should know why we divide by n-1 and not n. Remember about bias? I talked about that. Although I'm not going to ask on that, but you know, you should know it anyways. You should have a conceptual understanding of standard deviation. Even if I don't ask a calculation problem. Remember, the more spread out stuff is from the mean, the greater the standard deviation.
Mhm.
So you should be able to look at a graph and have an intuitive understanding of how big the standard deviation is compared to another graph. Lots of high because the values are really far from the mean, low because the values are for the most part close to the mean, and somewhere in between because the values are just like all over the place. Okay, and that's it for chapter 13. Are there any questions on 13?
No.
Okay, so let's move on now to the final chapter.
Professor?
Yes, I didn't do it. What happens?
No, it's okay. Would you say to kind of not memorize, but focus on definitely the equations that were given in each chapter?
Yeah, I mean, the equations are your starting point.
Okay.
Right? If I say, what is this? And it requires an equation that you don't know the equation, you can't answer it.
Okay.
Whereas the conceptual stuff, you can always like derive, an explanation, an answer. You can come up with something out of off the top of your head. But if you don't have formulas down, you can't do anything.
Would it also be safe to assume that our exam will have similar questions to our quiz questions?
Yeah, I get it from the same place.
Okay.
Okay. So 14 was the normal model. The normal model is very important in statistics. It is the bell curve. And we spent an entire chapter on the bell curve. Very important chapter. Okay. We had the 68, 95, 99.7 rule, which I mentioned about what percent of the data you should expect to find between 2 points. We know that 95% are 2 deviations away, 68% was within 1, and almost all is within 3. So that terminology, almost all, that means 3. Whereas 2 means, or anything beyond 2 is unusual, almost all means anything within 3. And then we did some examples, and some examples, and more examples, and more examples. And then we had the z-score. Okay, the z-score is very important. You should definitely expect to see a z-score question on the test. No question about it.
And
Yeah.
okay. So for the z-score, because I was a little bit confused on it when we were going over it when we did this lesson.
Yeah.
So when it says, what is the z-score for a child who scores 115?
You do 115 minus 100 divided by 15. Z-score is 1.
Got it. Okay. So that's like, but like you wouldn't want us to write like 1 standard deviation to the right, or like.
Well, that's what the z-score of 1 means.
Okay.
It means you're 1 standard deviation to the right, but the z-score is just 1.
Okay, got it. Thank you.
Okay. So you can calculate all these z-scores with the formula, which is right here. And then you can compare distributions because, yes, Kanye West is taller than Kim. Fine. But compared to other men and her compared to other women, who's a taller one? Not compared to each other because they come from different demographics, but compared to their peers. And you can do that with z-scores. You can't just do that by comparing the raw data because they come from different places. So z-scores are very useful for that. And we also talked about z-scores to percentiles. We had the chart, we had the calculator, we had the computer. You can use any of them you want. You can bring this chart with you to the test. You can have your calculator that can do it. You can do it on the computer. I don't care. But you should know how to get from the z-score to the percentile. Because remember what a percentile is. It's the proportion of values less than that amount. So if I'm at the 30th percentile, that means 30% is less than me. So I would go to the z that corresponds to 30%, which is right here or so. And I would say that my z-score must be negative 0.5, approximately. Because negative 0.5 means 30 point something percent to the left. That's roughly the 30th percentile. And I can go back to this formula here and say, now that I have my z-score, can I compute what my actual data was? So the z-score is really the center. And then we did more examples and more examples and more examples and more examples and more examples. And then we did the t-score, which again, you get from the z-score. So the z-score is the most important. It gets to the t-score, it gets to the raw data, and it gets to the percentile. T-score via this formula, raw data via the formula above, and percentile via the chart or the computer or the calculator. So if you want to get from any one of those to any other one, go through the z-score. Don't say, oh, I have my t-score, let me calculate my z. Don't do it. Let me calculate my raw data. No, go first to z and then maneuver through until you get to your raw data. And we did another example, and that was the end of chapter 14. So it took a little quicker than I was expecting. I went through quick because I wanted to make sure I covered everything. But I've covered everything. So now is your time to ask me any questions while I finish my scrumptious dinner. By the way, in case anyone was wondering at home, I am now down 22 pounds. So,
Woohoo!
Wow.
I mean, cucumber crap. So,
Oh, Mr. Griffith.
Good.
yeah.
Cucumbers are good. Don't knock a cucumber.
Okay, I actually like them, I have to admit. I mean, I wouldn't like,
Oh, you know what you should put on them?
take it over Dippin' Dots or something, but what?
You should put tahine on your cucumber.
Gesundheit. What were you saying?
It's a spice blend.
A spice blend.
Professor, do you not know what tahine is either?
Oh my gosh.
I
Do you
don't-
like sour and lemony flavors?
No.
Maybe, I don't know.
I'm gonna show you a picture of it. Because you've probably seen it. Hold on.
Listen, I remember a couple of years ago going out to eat with one of my friends, one of my professor friends, and he asked me where I wanted to go eat, and I listed like 5 restaurants. And he was like, I just realized something, he says. I go, what's that? He goes, what the hell is that? He
You've
goes,
never seen that before?
it doesn't look familiar.
Oh
He
my
goes, I just realized you don't like good food. You just like food. I just like eating a lot. I like big meals. I don't care what they are. I just like eating.
Ugh, tahini is so good though. You can put it on fruit.
Tahini it's called?
Tahini, yeah.
All right, I'll look it up. I'll send the old man out to get some. So,
It's basically like salt and pepper and like lime. So it's really good on cucumber. I even put it on my eggs. It's good.
is it healthy?
Yes, it's like virtually no calories.
Yeah. All right. Well, I have my book here of what I'm allowed to eat.
Ooh, chamoy. Okay, sorry, someone just.
How come away?
Oh no. Okay, so what you need to do is you need to go to one of those fruit vendors that are on the street, and you need to let them put everything on it in order to experience everything good about it. So that's what you need to do. You'll find out what everything is once you do that.
Can I
Yes,
put-
chamoy on mangoes is greater than life. I agree.
Can I put them on
You
Dippin'
guys
Dots?
are really
or-
trying to ruin his diet, aren't you? Like he's gone so far, and we're just tempting him with tahini.
I know, you guys are horrible people.
No, that's
Terrible.
unhealthy. It's unhealthy stuff, and it's just a seasoning. It's not like a sauce that's dense.
Exactly.
That's a lot of
Tahini is
salt.
fine.
Oh,
No. Okay, well,
When's the exam due?
that's a good
yeah.
question.
You're posting it tomorrow, right?
I'm posting it tomorrow night, after my other class ends. They have class from 7. No, that's Thursday. They have class from 2 to 3:15 tomorrow. So I'm going to post it sometime after that class, but I have 2 more classes immediately following that. And I have my office hours in between. So I don't know if I'll have time until the end of the evening, but certainly by Thursday night, it'll be posted. And you will have Friday, Saturday, Sunday, and it will be due by class time on Monday.
Thank you.
Right? Okay. And it'll be 1,000 questions.
Oh, that's
Perfect.
lovely.
Oh, yeah. You'll have no problem, guys. No problem.
So for the rest of what's the rest of our content? Is it chapter 16 through what?
Well, let's take a look. Let me load up.
Also, when's the last day of this class?
Well, we're in week 11 now. So the last day of the class is going to be in 4 weeks.
4 weeks.
Week 15, right?
Oh my goodness.
Isn't our final on like December 10th? I
Something,
think
yeah.
that's fall.
Something like that, yeah. Let's take a look here.
Oh my god, cat.
8 more class periods. Let's see how many chapters we got left.
We have 8 more class periods?
Well, it's 4 more weeks, right? Monday, Wednesday, Monday, Wednesday, Monday, Wednesday, Monday, Wednesday.
Oh my gosh.
So we have next Wednesday off, right?
What's next Wednesday?
I was about to say, yeah, we have
Veterans Day.
Veterans Day.
Oh yeah, the 11th.
We don't have school?
We don't
Nope.
have Veterans Day.
It's Veterans Day.
I mean, horrible. I mean, what? I'm gonna miss you guys. but I'll manage. So let's take a look. We finished 15, right?
Yeah, we finished 15.
So I see a 16. I see an 18. I see a 20 and a 23. A 17, a 24, and a 25. 16, 18, 17, 23, 24, 25. Is that correct? Let me see this again. 16, 18, 17, 18. I see a 19, 20, 16, 17, 18, 19, 20. And then I see a 23, a 24, and a 25. I don't see a 21 and a 22.
So 8
Chapter.
chapters.
So I see 8 more chapters, but I don't know if we'll finish 8 more chapters. And if we don't, we don't. You know, we finish what we finish. I'm not gonna go fast just for the sake of finishing. Okay, so
Better.
whatever we finish, we finish. We got 7 more class periods plus. Yeah. So I would say at most 7 of those. Yeah, that's the best I can do. What is a diet you were on again? It's called Optavia, which I wouldn't necessarily recommend as anything better than any other diet in the world. It's just, if you want a diet, stick to something. All right. I mean, for me, my problem's always been sticking to it. So,
Quick question.
yeah.
According to CSUN's final exam schedule, is ours going to be December 14?
Okay.
Is it? 4 weeks.
I have it on my phone. Hold on.
So
I'll be on the diet for 10 days.
we have 1, 2, and
So
then we have
December, oh, I guess maybe, oh yeah, here we go. December 12th. Oh, that's 140.
I just pulled it up. It says December 14 from 8 p.m. to 10 p.m.
Well, there you have it. December 14th. That's a little over a month away.
Okay.
So like in terms of that, like what is it the final? Are we going to be on Zoom when we take the final?
I don't know. I've never really required anyone to be on Zoom for the other test.
And it's cumulative, right?
It's cumulative, yeah. I have to speak to the math department.
Okay.
Just maybe they feel that there are certain rules that don't have to be in place or should be in place. But as far as I know, it's cumulative. And as far as I know, it's on Zoom. Yeah, I've lost 10 pounds, 20 pounds, but actually 22. But you have to remember something. I put on like 10 pounds a day before because I ate all day long. All right. I always do that before I start a diet. So I can do like major loss the first day. It's all psychological. Okay. So of that 20 pounds, 10 of it really shouldn't count. And then of the 10 that does count, like 9.5 of that's water weight. So really I've lost like a pound. Okay. So it's not really as grand as it sounds. All right. It's all just, psychological. So
Accomplishment is an accomplishment.
well, thank you very much. I feel the same way. Yeah, I'm not sure. But when does it end?
Never.
It ends when I'm back to my fighting weight. When I was a kickboxer in my 20s.
Whoa, really?
Yeah.
That sounds fun.
It was until I lost, and then I said, I'm done with this. I don't want to fight anymore. I was 5-0, and then I lost, and I'm like, I'm done. If I can't have an undefeated record, what's the point, right? So, anyways, I used to fight at 175 pounds. That was my fighting weight. And 10 days ago, I was 287 pounds.
Ooh.
So, I mean, a lot of it was this, but a lot of it was not that. So, you can understand that. I don't like to use the F word, but I'll say it's non-muscle. We'll just do that.
Did you see the comment section, Professor?
How many boxes did you kick? I kicked 1 or 2. No, I know you're like, what, him? But yeah, I was different back in the day. Besides having the hair, I also was a pretty good athlete. I remember I was playing tennis like last year, because I'm on a tennis team, and I played against this guy, and he was very good. He beat me. I mean, he was a good player. But at one point, he said to me, he goes, "Wow, you're surprisingly fast." That's what he said. You're surprisingly fast. Like such a backhand compliment. Like, wow,
Just
you're
say what a
fast.
backhanded asshole.
Yeah, I know he was a nice guy. I don't think he meant it, in a bad way. But it was like, you're surprisingly fast. It was kind of,
He
Anyways,
probably likes serving backhanded comments.
wow, that was horrible. Anyway, so so are there any other questions for today's review?
No,
No questions?
not for me at least.
Okay, well, I don't necessarily want to keep everyone here. If you feel that you are good to go. Am I working out too? No exercise. Not until I lose another. I guess I'll go back and start playing tennis again and maybe 30 more pounds. I've had a lot of back pain even before COVID started from just, putting on a lot of weight. And my last match, I was in a lot of pain. It was very, between sets, I was actually lying on my back on the ground to try to alleviate the pain. That's how bad it was, which at the same time ended up helping us win because the opponents kept hitting to me. I'm not my partner. I play doubles and not my partner. And I don't know if any of you ever played through pain, but you know that when you're in the middle of a point, you just ignore the pain because you're playing the point. So they keep hitting to me because I was like walking like this between points, but in the middle of a point, I got no problem. And then, so I was the better player. My partner wasn't as good as I was. So they kept hitting to me and then they ended up losing and it was like, boom, in your face. But anyways.
Adrenaline.
Yeah, they were nice people, but they were stupid, bad strategy. If you have access to a pool, I do not have, well, I guess I have access to a pool in theory, but with COVID-19, I'm not sure if people are out, in pools anymore. But no, hey, listen, whatever I'm doing is working, right? 22 pounds in 10 days. You can't knock that, even though 19 and a half of it doesn't really count. So we'll just keep going.
What do you mean? Why doesn't 19 and a half of it count?
I explained 10 of it was working off what I ate the day before, and then 9.5 was water weight. So it's only been like 1.5 pounds of real weight that I've lost. Until you see a thinner face and you're like, wow, you're losing weight. Until I hear that from one of you, it just doesn't count. That's my rule.
Progress matters.
Yeah, well. Anyways, anywho, well, Evelyn, if you really want to try this particular one out, send me an email because my sister, by the way, who's lost 58 pounds on it, and my mom who's lost 27 pounds on it, and my brother's lost 35 pounds on it. But I believe if they refer someone, they get a little discount. I don't need the discount myself. I make enough, but they kind of do. So if you do want to do that, send me an email and I'll pass you on to them so they can get a little kickback if that's okay. And if anyone else, a lot of you are not on camera, so I don't know whether or not you want, or I wouldn't even know either way. I don't care what you look like. Hey, everyone's beautiful, right? That's the nonsense that everyone says these days. Everyone's beautiful. But if you feel that you want to lose weight, then you reach out to me. I'm not going to say, you can lose a few pounds. I'm not going to do that. So if you reach out to me and say, hey, I'm interested, then I will pass you on to them. Okay, so just send me an email about that if you're truly interested. All I know is that I've really tried to lose weight for many, many years and never really been successful. And this one, the food is not great, but I'm never hungry in 10 days. I have like 1,000 calories a day, which is not a lot, and I'm never hungry.
That's good.
Yeah, so it's so far so good. Anyways, guys, thank you, Alex. Thank you, everyone. Go study hard or cheat, whatever you're gonna do. I don't care, but I will see you all next Monday.
You just incriminated yourself. You're still recording.
Yeah, I know, but whoever watches this knows that I'm joking. I hope they know they're joking. I was crossing my fingers over here. You didn't see it, but they were. Have a good time, and I will see you all next week.
Thank you.
Yes, sir.
Okay, bye-bye. Okay. That is one weird freezing spot. All right, I'm still recording.